Welcome, my friend. Today's story begins with a mystery that completely changed what scientists thought they knew about the history of Europe. How could the coldest region on the continent have been home, for thousands of years, to people whose skin looked more like that of North African hunter-gatherers than the Europeans we know today? The year was 2014. A team of geneticists opened an ancient burial site in central Sweden, at a place called Motala. The graves lay beside a lake that had remained covered in ice until only a few thousand years ago. Inside, they found the remains of hunter-gatherers who had lived nearly 8,000 years ago. At first glance, nothing seemed unusual. Similar skeletons had already been discovered across Scandinavia. But this time, the researchers decided to do something that had never been done with these remains before. They sequenced the complete genomes of the people buried there. What they found was so unexpected that the results were published in Nature*. The people of Motala lived in what is now one of the fairest-skinned countries on Earth, yet genetically, they had dark skin. Not slightly darker, truly dark skin, similar to the pigmentation seen today in many North African populations. And that wasn't even the biggest surprise. They had blue eyes. One of the rarest combinations in the modern world was preserved inside an 8,000-year-old skeleton from Sweden. Take a moment to think about that. Sweden, a country that has become a global symbol of blonde hair, fair skin, and light-colored eyes. Yet the people who lived there thousands of years, if were modern Swedes, looked completely different. If you met them today, you probably wouldn't even guess they were European. Which leads to an extraordinary conclusion. Sweden wasn't born white. It became white. And understanding how that happened forces us to rethink everything we believe about human skin color. To understand the people of Motala, we need to travel much further back, to the very beginning of our own species. Around 300,000 years ago, when Homo sapiens first appeared in Africa, light skin didn't exist anywhere on Earth, not in most people. In everyone, one species, one continent, one skin tone. The oldest known human fossils, discovered at Jebel Irhoud in present-day Morocco, obviously don't preserve skin. Fossils preserve bones, not pigmentation. But both the environment where these early humans lived and the genetics of modern populations point to the same conclusion. Life beneath the intense equatorial sun demanded enormous amounts of melanin simply to survive. Melanin is the dark pigment produced by our skin. Its primary job is to absorb harmful ultraviolet radiation before it can damage the deeper layers of the body. And that radiation isn't just a cosmetic concern, it attacks the DNA inside our cells. Over time, that damage can lead to skin cancer, including melanoma, one of the deadliest forms of the disease. But cancer wasn't the main evolutionary pressure. Another factor turned out to be even more important. Ultraviolet radiation destroys folate, a vitamin essential for the healthy development of a baby's nervous system during pregnancy. When folate levels drop to low, the risk of severe birth defects rises dramatically. Conditions like spina bifida become much more likely. For light-skinned women living beneath the intense African sun, this created a serious problem. Their folate reserves could be depleted before pregnancy was complete. Fewer babies survived. Those genes gradually disappeared from the population. Generation after generation, natural selection favored darker skin. For hundreds of thousands of years, that process shaped every human being on Earth, but humanity didn't stay in Africa forever. Over tens of thousands of years, small groups of people began leaving the continent. They crossed the Arabian Peninsula, spread into Eurasia, and gradually moved farther and farther away from the equator. As they traveled north, something fundamental changed. The sun grew weaker. In northern Europe, especially during winter, ultraviolet radiation reaching the ground is incredibly limited. And that completely changed the rules of survival. Near the equator, too much sunlight was the danger. In the far north, the real threat became too little sunlight. This is where another key piece of the puzzle enters the story. Vitamin D, unlike most vitamins, the human body produces vitamin D, and the skin is exposed to ultraviolet light. Without enough vitamin D, calcium cannot be absorbed efficiently. Bones become weak, children struggle to grow properly. The immune system becomes less effective, diseases such as rickets become common, and infections become far more dangerous. Suddenly, The same dark skin that had protected human beings for hundreds of thousands of years became a disadvantage. Not because dark skin was flawed, but because it blocked the little ultraviolet light available in northern climates. People whose skin happened to be slightly lighter could produce more vitamin D from the limited sunlight they received. Their children were healthier, they survived more often. Over many generations, those genetic variants slowly became more common. At first glance, that sounds like a simple explanation for why Europeans eventually developed lighter skin. But then we return to Motala, and everything becomes strange again. If lighter skin offered such an advantage in Northern Europe, why were Swedish hunter-gatherers still dark-skinned 8,000 years ago? The answer reveals something most people misunderstand about evolution. Evolution is slow, very slow. The genes responsible for the fair skin seen in most modern Europeans simply hadn't reached Scandinavia yet. They didn't evolve there, they arrived from somewhere else. The turning point began around 9,000 years ago. In what is now Turkey and parts of the Middle East, farming communities were expanding rapidly. These early farmers weren't just carrying seeds, livestock, and new technologies. They were also carrying new genetic variations. One of the most important was a version of a gene called **SLC2 for A5***. This gene reduces the production of melanin, resulting in lighter skin. As farming spread across Europe, so did this genetic variant. Beginning roughly 8,000 years ago, it moved gradually through southern and central Europe. But by then, the hunter-gatherers of Motala had already lived and died. They never inherited it. Thousands of years later, another important mutation began spreading across Europe. This time, it involved a different gene known as **SLC for 5A2***. That variant became widespread only around 6,000 years ago. In other words, the fair skin we now associate with Europe didn't appear overnight. It wasn't there from the beginning. And it wasn't an original feature of Europe's earliest inhabitants, it arrived through migration. Then, generation after generation, it slowly replaced the darker pigmentation that had existed there for thousands of years, region by region. Century after century, the people buried at Motala simply lived too early to become part of that transformation. Their DNA preserved a snapshot of Europe before Europe looked the way we imagine it today. And that's exactly what makes their discoveries so extraordinary. But Europe wasn't the only place where this evolutionary puzzle unfolded. On the other side of the world, people living across East Asia faced the very same challenge: weak sunlight, long winters, and the constant risk of vitamin D deficiency. You might expect nature to solve the problem the same way. After all, lighter skin improves vitamin D production under low levels of ultraviolet radiation. The outcome was similar, but the path was completely different. Instead of relying on the same genetic variants that spread through Europe, East Asian populations evolved lighter skin through different genes. In other words, two populations living under similar environmental conditions arrived at a similar physical appearance, using entirely different genetic solutions. Biologists have a name for this phenomenon: convergent evolution. It's what happens when nature solves the same problem more than once, but by taking different evolutionary paths. It's the same reason birds and bats both developed wings. The result looks similar, but the biological root is entirely different. Human skin color tells exactly the same kind of story. And then there's a population that seems to break the rules altogether. The Inuit. They live in some of the harshest environments on Earth, across Alaska, northern Canada, and Greenland. They inhabit regions much farther from the equator than almost anyone else on the planet. If latitude alone determines skin color, the Inuit should have some of the lightest skin in the world. But they don't. Their skin is generally darker than that of Scandinavians living at similar latitudes. At first, that seems like a contradiction until you look at their diet. For thousands of years, traditional Inuit meals have consisted largely of fatty fish, seals, whales, and the organs of marine animals. Foods that are naturally rich in vitamin D. Because they obtained large amounts of vitamin D directly from what they ate, their bodies weren't nearly as dependent on sunlight to survive. The evolutionary pressure to develop lighter skin was dramatically reduced. Nature had already solved the problem. Not through genetics, but through nutrition. This single example reveals something incredibly important. Skin color has never been determined by latitude alone. It has always been shaped by multiple forces acting together: sunlight, diet, migration, time, chance. Every population followed its own evolutionary path. Every population tells a different story, and that's exactly why human skin color is far more complex than most people imagine. In fact, the closer scientists looked at our DNA, the more surprising the picture became. For centuries, people tried to divide humanity into separate biological races based largely on skin color. Those ideas were used to justify slavery, colonialism, segregation, and countless forms of discrimination. Modern genetics tells a very different story. Skin color isn't controlled by a single gene, or even by just a few genes. It's a polygenic trait influenced by well over 100 different genetic variants. These genes don't travel together as fixed packages. They mix, separate, recombine, and spread independently across populations over thousands of years. In other words, there is no genetic boundary, or one so-called race ends and another begins. Instead, humanity exists along a continuous spectrum of genetic variation. One of the most influential studies on this subject was published in *Science* in 2017 by geneticist Sarah Tishkoff and her research team. Their work revealed something remarkable. Many genetic variants associated with lighter skin had already existed within African populations for hundreds of thousands of years. Some of them appeared long before Homo sapiens became the species we recognize today. Even more surprising, Africa contains the greatest diversity of skin tones found anywhere on Earth, greater than the differences between Africa and the rest of the world combined. That completely overturns the traditional idea of race as a fixed biological category. The DNA simply doesn't support it. What actually exists is a continuous mosaic of human diversity, constantly reshaped by climate, migration, diet, and evolution. Humanity has never been divided into neat biological boxes. It has always been connected. Now let's return to that frozen lake in Motala. Picture those hunter-gatherers once more. They lived 8,000 years ago. They had dark skin, they had striking blue eyes, and they were buried in a land that the modern world now associates almost entirely with fair skin. They weren't an exception, they weren't an anomaly, and they certainly weren't a mistake in the archaeological record. They were a genuine snapshot of what Europe once looked like, long before Europe became the Europe we recognize today. Their skin color didn't define who they were. It didn't determine their intelligence, their culture, their identity, or their place in history. It reflected only one thing: the environments where their ancestors had lived long enough for natural selection to leave its mark. Their skin was an evolutionary record, not a measure of human value. In many ways, it was simply an address written into their DNA, not an identity. And perhaps that's the most remarkable lesson this discovery has to offer. Even something that feels permanent, something we often think we're born with forever, can change over time. Human skin color has changed repeatedly throughout our history. It has responded to shifting climates, changing diets, new migrations, and countless generations of evolution. It has never stood still, which leaves us with one final question. If something as visible and as deeply personal as skin color is simply one stage in an ongoing evolutionary journey, what other things do we treat as permanent, when they're really just temporary chapters in a story that's still being written? Science has a way of challenging our assumptions. Sometimes, it doesn't just change what we know, it changes the questions we ask. And perhaps that's the greatest discovery of all. If this story surprised you, let us know in the comments what fact changed the way you think about human history. And if you enjoy exploring the hidden stories behind science, evolution, and the origins of our species, don't forget to like this video and subscribe to the channel, because there are still many incredible chapters of human history waiting to be uncovered, and we'll see you in the next one.